Hi, in this video we're going to be looking at how to work this loop card for finding the equation of straight line graphs from the graphs and writing them out in algebraic form. So we're going to start on card 1 and see how this works. So here's card 1, and the first thing we need to appreciate is that the equation of straight line graphs usually works in the form y is equal to mx plus c. Okay, so what's going on here is obviously y is just the y coordinate, x is just the x coordinate, and the multiplier m is the gradient of the line. Right, gradient as grad rather than grid, and c is the y-intercept. Okay, so hopefully we should figure out how this works. So the first thing to have a look at on this graph, card 1, says card 1, is where is the y-intercept? Well, the line goes through the y-axis at -2. Okay, so we've got half the answer there. So second part of the problem is to work out what the gradient of the line is. The first thing I always like to think about is when you put an arrow on the line on the right hand side, is it going up or down? If it's going up, then the gradient is positive. Okay, so that's just the first thing to think about. Second thing is we need to find where the grid intersections cross when we think about the line. So I need 2 points to draw a triangle with, and the 2 points on the line have got to be where the grid intersections happen. So for example, this point here is no good to us because it's not on a cross on the lines. Okay, whereas this one would be fine because it's where the x and the y grids cross over. So it's all about just trying to be able to read the numbers off easy. If you're halfway between grid nodes, it's going to be really just complicated. Okay, so another point would probably be here. That would work. And I'm just going to draw a little triangle. Okay, so how big's that? That's 2. How big's that? That's 1. Okay, now the gradient is equal to the change in y divided by the change in x. Okay, so here my change in y is 2, my change in x is 1. Okay, so my gradient is 2. Okie dokie. So let's just put that in red because that's what we wanted to think about. Now, is our 2 positive or negative? Well, we said here that our gradient's positive, so this must be a positive 2. The long way of thinking about this is really that when we think about the x direction being positive to the right and the y direction being positive up, because our triangle is going positive in x and positive in y, then our numbers that we divide are positive 2 and positive 1, and that gives us positive 2. And if the lines going the other way, then you get negatives and you get negative gradients. But the simpler way is just where is the line going? Is it going up or down? So where do we get to? So y is equal to, and we said the gradient was 2x, and we said the y-intercept was -2. Okay, so there's your answer to the problem, and the question is, like, where do you go in the card next? So what you've got to do is have a look at the card. All the answers are up the top in boxes. Okay, so we just need to have a look at all the answers, and we're going to find out that card 9 has got our answer. Yep, so card 9 is saying y is 2x take away 2. That was my answer, card 9. So I'm just going to say down in the box here, I'm going to card 9 next. Okay, as if by magic, here we go, there's card 9. So we're going to do the same thing again now. So we're going to put an arrow on the right hand side, lines going down, so that's a negative gradient. That's the first thing we just need to note. And the y-axis intercept is here, that's just 1. And then we need to think about a triangle. It doesn't matter where you put the little dots for the triangle, but it's got to be where the grid nodes intersect. So we could choose, for example, here and here, draw a little triangle. So we're going, here we're going down 1, and we're going across 2. So the gradient is equal to the change in y divided by the change x, which is equal to minus 1 divided by 2, which is equal to minus a half. Okay, so our answer here is going to be y is equal to minus a half x plus 1, which is absolutely perfect and correct. Now sometimes in maths we don't like these minus signs flapping out the front, and sometimes we just like to tidy it up. So in this case we'd probably tidy this up and say it's 1 take away half x. So we have a look on the grid card. Now where do we get, so we don't know whether it's going to be in, it'll be in either one of those flavours, right? It'll either say y is minus x plus 1 or y is 1 take away half x. It's going to be one of those. So let's have a look. So no. Let's get that on the screen. There we go. So card 4, 1 take away half x. That was our 1, right? So we're going to say, boom, card 4. So there we go and do card 4, and so on and so forth. And if you do this loop card correctly, what you're going to find is you've got a decent answer for every single card. And the last thing you'll find out you're doing is going from your last answer back to card 1. If you get back to card 1 and you've not completed all the cards, something's gone wonky. Okay, so if you want to give that a go, that'd be fantastic. And I can even pop the answers up somewhere else later. Okay, bye.